Hello, everyone, and welcome to Open Mic Sunday. Basically, guys, if you want to get on and talk to me, just let me know, and I'll shoot you a link, and we can get in here and chat. Uh, Looks like Bernie's going to be here today, so he may be hanging out with us as well. So, anyway, question in the chat already. Good afternoon. Let's see. Put it up. Your Tesla coil, more specifically cold energy, would it be possible to cycle nitrogen through the center? Well, the idea is to actually have it cool on its own, though I do understand cooling it faster. I had talked to Gerald about his coil and adding some cold, basically air conditioning or something like that, just to see if it helps out with getting to a superconductive state. It would be interesting to try it, but I do not know the answer to that at this point. Basically, I got several coils. The one behind me, you can see it, that side. It's 4 inches in diameter and almost 2 feet tall. So some cold air through the center and then pulling out the energy. Yeah. So I also did have a question, guys, a little while somebody had sent it to my comments. And they asked me how to reduce the frequency of your Tesla coil. So when you take your Tesla coil, all you want to do, instead of shoving a pipe down it, because it'll ruin your circuits right away, if you run a Slayer exciter or a ZVS circuitry, then it may blow the circuits because it puts heat back to them. So it's not the best way to do it. So what you want to do is simply take a plate, connect the wire to that plate, and put the wire down the center of the Tesla coil. Now, I know it doesn't seem like it's going to do it, but based on the mass of the object that you put to it, it's going to lower the frequency of your Tesla coil. So what would I suggest? Something, I don't know, maybe 1 foot by 1 foot, maybe an 1/8 inch thick, just to start so you can see how to calculate this thing. Then you can always add extra plates. You can always go thicker on the plates later, but first just see where you're at. So say, for instance, you're at 300 kilohertz, and all you want to do is drop this thing down to maybe 400 kilohertz or 400 hertz in the hertz single. So basically what you want to do is connect the plate to a wire, put the wire down the center, make sure it doesn't touch the sides, doesn't touch the top, just goes directly down the center. If you got a 3D printer, print something to make it go down the center. And then see exactly what the drop is. Now, if it's just a standard piece of aluminum and it's 1 foot by 1 foot, it's probably going to drop, I don't know, maybe 100 hertz, maybe 200 hertz, something like that. So as you get the mass up about 3 pounds, it'll drop 300 kilohertz. So just kind of a scale in there somewhere. I just usually do it with my gravity flyer. So I know my gravity flyer is 3 pounds of almost solid metal. And that right there drops at 300 kilohertz. So what's the idea here? Basically what you're doing is you're adding more coils to it without adding more coils to it. So is it a load or is it capacitance? And it kind of falls in that in between. I always call it capacitance. Some people would call it a load. They would say, well, it's like just putting a load on the top, but it acts different. So it'll drop the frequency of your Tesla coil. So it's more like capacitance in this state. So what's going on here is when we put that wire in there, based on the total amount of mass that you have it connected to, it's going to drop the frequency. So I just think of it like this. If you want to get to the kilohertz, you're in 300 kilohertz, right? And you want to get to the hertz, and you want to get around 400 hertz, what I would simply do is take something that weighs 2 pounds, connect it to it that's metal, any configuration, connect a wire to it, put it down the throat, and get yourself in, the hertz range. Then add and remove weight as you want, and then you'll be able to get there. That's probably the best way to do it. Now, what I would caution you on is when you get down to that, you're talking frequencies of your tuning forks. So you're going to get some things going in resonance. If you put a tuning fork close enough to the top of that Tesla coil, it may ring. However, you may need to put, I don't want to say it, like a flat piece on the bottom of your Tesla coil so that it actually acts as a closed container so that you could put your tuning fork right down into this over by the center of it, because you got to create sound out of this. And you're creating basically two magnetic fields right there that oscillate in order to get sound out of it. Sound's movement, and usually your tuning fork, in order to ring, needs that sound in order to get it to amplify. That's how the two boxes work, is the sound goes from one to the next. Now, the frequency is important. So will it ring directly next to your Tesla coil? It might, but you also may be adding capacitance to your coil just by standing next to it. So what's the best thing to do? Get it on a little stand, put it right above your Tesla coil, and go for it. Just make sure you don't have the top tip connected, that the wire's just hanging out to the side. That's the way I'd try it if you actually want to get into the hertz area of your Tesla coil and check it out versus a tuning fork. Once you get that, man, the whole world is wide open for you on a Tesla coil. You can play with it all day. You can match them up. You can do anything you want with those things if you know how to do it. That's the way I would get it down to the low hertz area, so you can start ringing your tuning forks. So anyway, just that was a question that I had earlier in one of the comments of the video, so I thought I'd address it today and tell you how I did it. It won't impede the circuit on the Slayer exciter or blow it up or put any heat back to the transistor. What it's basically doing, because it's the wire, it sees it as a low impedance wire. Now, if I just took a big giant pipe down there, the heat would blow it up. So there is a correlation to it. I always say put the wire down and connect the wire to something else. You'll still get the hertz in the right area. If you put a giant pipe down it, you're going to start blowing circuits. And that just has to do with how that circuit is, and you're automatically forcing it to oscillate incorrectly with that pipe in there. That's why you use a small wire. What kind of wire? Just use a cheap wire. Okay. I'm talking something that you would put on the trailer of your boat trailer or something that's really, really low shielding on it. That way it'll transfer easily through there and it'll be able to pick it up. One of the cool things is if you put it on a rotating disc, it'll make a field out of it. And that field will push out just like this. As fast as you rotate it, it'll push out further, slow it down, and it'll push back in. That's really awesome about that. Now, say you want to take advantage of that and put it on like a disc and then a plate right underneath it, right? So now connect your a DC flyback to the plate on the bottom, just the positive side, and then connect your Tesla coil to the top. You're going to get an interaction. You're going to get a field on the bottom and a field on the top, and then it'll be able to encompass the field around that Tesla coil field. Totally cool effect. You'll be able, if you adjust both of them just right, you'll get them to interact. And then when you put your light right there, man, it'll shine super bright. You move it in a little bit, it'll get dimmer. You move it out past where that line is, it'll get dimmer. Put it right back on that line, man, bright as day. So it's just a really cool effect that I've noticed when I start mapping out stuff on the Tesla coil. Again, usually I do it on my gravity flyer, so I have all the spinning discs and all the plates and everything already connected to it. But it doesn't necessarily need to be that way. It could just be however you want it to be. So that's my thought on it. So I thought I'd tell you that. Okay. Let's see. Do the electric circuit. Yeah, you may cool down that copper, but the outside has to be hot and the inside has to be cool in order to make, I want to say this. I want to say it's an electron that does it, okay? But you can correct me if you want. Basically, what it's going to do is your Tesla coil is a cylinder, okay? And then the flow in the center, once you put something in there, it goes like this and it comes back around. Okay, that's the field you're getting, but it's 360 degrees. Okay, you got to remember that because obviously a round pipe. So, how do I say this? So once you do that, if it's big enough gap in the center, okay, you're going to get the flow to go through there. Okay, and then you're going to get more energy added to it. Now, if you cool it down, is it going to make the energy go faster or anything like that? It depends how high you turn up your Tesla coil. Because as much as it's pushing out, it also has to push a field inside, okay? But the inside field is a lot less. It's more cold in there, and that's because of that flow, okay? That flow in there, keep that thing cold. While the outside gets hot, sometimes, man, you get this sucker cranked up enough and you're going to feel like a heater's on in the room. And you're going to go over to the center of that going, why is it room temperature right now? Or why is it lower than room temperature? And that's why it's that flow. It's always that flow and how these things work. So it's an open air transformer. I mean, that's the way they're supposed to work. So hopefully that answered everybody's question on that. Silver holds the best frequencies. I don't know. You could be 100% right. I don't generally work with silver or gold. I'm not rich enough to do that. So everybody's saying hi this morning, man. Right on. Thoughts of using the thermodynamic effect on the. Yeah, it's like I said, the same thing. I think honestly, man, I think it's going to get cool on its own. And the more you can put it in that state, the cooler it's going to get. But the wider your Tesla coil may need to be. So 4 inches is good. On a 2-inch pipe, there's not really much of a temperature difference there. There's not enough distance in that. At a 4-inch, you get a lot more distance. You get a lot more temperature change. So, by the way, when you connect that wire to the mass, what you're going to find is it'll be cool. It'll be in like the 70s is the temperature, so 70 Fahrenheit. And what'll happen is you'll feel it and you go, well, that's pretty cool. But then you touch the edge of it and it'll burn your finger. So it's still cool, but it burns you. So that's what I say when I say cold energy, negative energy. That's what we're looking at here. You're getting the opposite side of the energy. So you get the hot on the Tesla coil on the outside. On the inside, you get the cool or negative energy. That's how you're going to get it. Winding it left, winding it right. I've never gotten energy to be different doing that. I've tried. I have both. Never gotten it. Never gotten a cold side out of it. It's always heat coming out of it. Never been a difference. Putting the wire down the Tesla coil made the difference. So, let's see. Air's small enough opening. Yeah, you wanted a little, like 4 inches is perfect size. I wouldn't go bigger than that, and I wouldn't go smaller. Okay. Let's see. What else we got here? It looks like a donut, essentially. Absolutely, it does. So, what's going on? By the way, to the toy maker, I want to say thank you. He always told me about Steinmetz for, a year now? Maybe half a year? And when I looked into it, and I looked into the dielectric, he was absolutely right. That field, I was using it, didn't know what it was, and he knew what it was. I didn't. So I have to say thank you to him, because when I started reading through the Steinmetz papers, it became very evident in one of my things that I do for my testing. You've all seen the little paper UFO that I did, and I have a plate up here and a plate down here. And basically, I hook my DC flyback to both plates, positive and negative. And what happens is, depending on the size of the plate, if it's smaller, the thing will go in that direction. So, it goes towards the bigger plate from the smaller plate. So, when I have the smaller plate on the bottom, bigger plate on top, it'll actually pull up. And what's going on is it's that dielectric field in there. And because the paper is actually a mesh, it is not styrofoam. Styrofoams are balls that are pressed together. That'll charge for a long time, but it takes forever to charge. And the amount of pressure sucks. Okay, it just does. So when you actually use the paper in there, that paper mesh creates a heavier amount of charge on it because of the mesh. Okay, that's what's going on. So it'll push up there to the top and stay. And again, we're using DC, but I'm taking out all the amps just about. We're in like microamps, milliamps in that little small area. So that force right there is so much higher. So when you run it in the opposite direction, and I have the small on the top and the big on the bottom, and it could be a cone, it could be anything, okay? As long as it has that field on it, the force on it is way heavier, okay? It will, push grams like they're nothing, okay? Now, how do you get that to amplify? Well, this is when you start thinking about T.T. Brown. When he started creating capacitance, right, in the plates, just think of it this way. You have a mesh, you have a piece of plastic and a mesh, okay? And a couple layers of mesh in there, plastic, couple layers of mesh. What are you trying to do? You want to take the circumference of it or the radius of it, and you want that round circle to be a lot so that it can hit multiple layers on it, right? So it'll do that, and then the plastic will divide it so that it can't get to each other. However, all of them pull down. So it's a little different understanding. Do you have to have plastic in there? No. You could just, one little paper lifter, make it thinner, and then get multiple ones on there. That's when you start getting that weight way up there. So you're going to go from grams to pounds when you do that, or at least 1 pound. And it'll start to create a heavier force in one direction. And it's because of the dielectric. Now, you can move the plates a little bit closer together, okay, as long as you do not get any ion wind or any kind of breakout from top to bottom in the way of light. So when you turn off the lights and look at it, if you got a glow in there, you got a hissing sound, you're off the mark. You're not in dielectric right there. You are in a plasma state. You got to get out of that. So just lift it a little bit, get yourself into that dielectric state, and man, you're good to go. So that's a little bit of understanding on that. I use 2 DC flybacks in series in order to get to that level. And then it gives you a perfect amount of charge to be able to put on there. It's instantaneous. It works right away. No issues. And it's so much easier. Just understand it this way. If you get to a plasma state, you're using the energy before you can use it to compress something. So you're wasting the energy. It's like turn on your air conditioner and leaving your windows wide open. It's a complete waste when it comes to this. You want to keep everything good. You want to get it right before it gets to that state, and it'll give you the maximum amount of a dielectric that you want in there. Anyway, I just want to say thank Toymaker again. Thank you for telling me that. I should have listened earlier. You're 100% right. Okay. You did an experiment this week where you attached a mirror to a Dremel and bounced my laser off it while it spun at 30K RPM. What was the result of that? Let's see if we have a result. Let's see. It turned the laser to a point into a circle with a dark shadow in the middle. When I get close to the edge of it, the mirror, it seems to light in an arc. Really? I've never seen that. I'll have to try that. That looks really interesting. Okay. When I overlap that ring on the camera, It flashes left to right. I got a videotape of it on YouTube. Oh, we'll have to check that out. So, all right, let me go back up here a little bit. Something like that. You want to talk about the RPM on the gravity flyer? Well, this is probably going to disappoint a lot of people. Everybody thinks it's like 4,000 RPM, 3,000 RPM. It's not. PC fan motors don't go that fast. When you start adding weight to them, they go even slower. We're about 600 RPM at max on the bottom and 1,400 RPM on the top. And at those speeds, you're not going to hit the right range. You actually want the top to go down to about 1,000 RPM, and you need that bottom to get as much possible speed as you can. The reason is when you put your voltage in on both plates, and that's from the DC flyback, you want them to start to set in harmonics together, and they won't do that if they're too far off from each other. So you have to keep them kind of consistent. Now, as soon as they get to that level, the eddy current in it will slow the actual top one down a bit, and that'll help. But as soon as the energy picks up on it, it'll actually slow down the top one as well. So that'll get it closer. You're looking for maybe an increase on the bottom and a decrease on the top. You're going to meet anywhere from 650 RPM on the bottom, and you're looking at right around 800 RPM on the top, maybe a little bit less by the time it all gets done. What starts to happen on your gravity flyer at that point is you're going to get an angular momentum, okay? Just like this. And you're going to get it to turn just a little bit, and you'll see it just start to shake a little bit too. Right there, you know that those two things are coupled, and you're good to go, okay? And you'll start picking up more energy. Now, there was a thing that had to do with the spark coming off the foot when it's on concrete, and that has to do with the amount of energy you're putting into this thing, but also the amount of energy you're pumping out of the ground. A lot of people don't know this, is you're double grounding. So your Tesla coil is grounded, your gravity flyer is now grounded. You've got to create a circuit on the ground, right there under the ground. So if you're outside, it's going to go under the ground a little bit. If you're on concrete, it's usually riding, the surface or right under it. And what it'll do is it'll start to amplify the energy in it. And if you're in the correct zone, so say you have the correct octave in it, and that's what I always call it, because it's like a tune in the singer. You have to be in the right one, and it just has to do with the harmonics of it. So if you're out of tune on the harmonics, if you're, A flat versus A sharp, you know what I mean, or something like that, it makes a big difference. You'll get sympathetic resonance instead of regular resonance. You want regular resonance out of it. Then you'll start to pick up energy. And depending on how much energy you have put into it from your Tesla coil and also your DC flyback, that amount of energy gets multiplied. Now, as you have it outside and you have it connected to the ground as that ground, you start pumping it to the ground. I know that sounds weird, but you got to think of your Tesla coil as an oscillating pump, okay? But then your gravity flyer is on the ground. So it now is becoming an oscillating pump as well. So what happens? You start to pull that energy in. It'll show up on your oscilloscope as a third ring. And I usually attribute it to the magnets, because the magnet's rotating, the pump working like that, it's doing the same thing. So I'm getting two fields, one from the magnet, one from the actual Tesla coil that's connected. It's creating that pump in there. Now, since the wires are so cheap on this thing, and no, I don't want to overpower them by putting in better wires, it actually creates the ring through all three. Your frequency, even though you may be putting in 300 kilohertz, it's going to be 25 megahertz. And I know that's a drastic difference, but that double grounding and that pump action and the fact that everything in there on the wires takes on a frequency, because they're so cheap, it's a rider to the actual voltage on it. it'll actually change all of it to the same thing. So now what you're looking at is you're going to amplify the 25 megahertz frequency. That's why you pick up so much power. It's the frequency that you go to. You're overriding everything, including the Tesla coil. The Tesla coil becomes reserve energy in this circuit. You know what I mean? That's actually pumping. So why is it important to do that? Well, you need energy of the earth to be in a contradiction to it, or to create a temperature, or not temperature, but a pressure differential between the earth and the actual gravity flyer. And we don't have the correct energy to put into it to match the earth frequency, or excuse me, not the frequency, the earth energy. That's the problem here. We're in DC, we're in AC, we're in man-made energy. We are not in energy of the earth. That's why when you pump it right out of the ground, so you test the coil, you would think it's putting it in. It's really not. It's pulling it out of the ground. When you have it connected there, you're actually getting energy pulled into it from the ground. So that's why it's important, because now you can start to build up the field, because the Tesla coil is going to put that field around that gravity flyer. There's no question about that. Then the top and bottom disc is going to be able to push out that. You don't want it necessarily in a static state, okay? But you want energy that comes off of it, okay? You want it in a scalar state, so that when it comes out, it's forced to move inside the bubble, okay? And it'll thicken the bubble on the outside for you a little bit. As you're pumping in the energy from the earth, everything else that's in there will scatter and dissipate right out of the gravity flyer. This is the only way to get something like this to lift with this much mass. So you can get a lifter to do it. You can get other things to do it. But with this much mass, you have to create the field, and you have to be able to pump that energy into it. So I don't know of any other way to say to it. It's just a pressure differential. It's kind of like you say a hot air balloon. You say, well, that's all heat. Well, yeah, but there's a pressure differential as well. So between the inside and the outside, there's different pressures, okay? Kind of goes to, you know what I mean, when you go to pull all your air out of your vacuum chamber and you want to simulate space, and you do the math for that, right? But then you forget we're not in a negative environment on the earth. We're in a positive environment on the earth. So you actually need to pump in more and completely create something inside that negative environment. So you got a negative box, okay? It's filled, it's pulled out the pressure. Now you need to add pressure and create a balloon in there with that pressure. That's why some of these readings are inaccurate when you start to do the math on them, because you have to realize what you're in. We're in a pressurized system in here. We're not in space where it's depressurized, if that makes sense to you. So, but the gravity flyer has to be better outside, harder to get it to lift inside. It takes longer in the inside, that's for sure. Have I gotten it to lift? I'll just say that it gets up on one leg. Okay, it's showing every bit of sign to lift. Now, because there's energy in the ground, I can't tell you if it's the energy in the ground doing it or it's actually the field itself. So until I determine that, I don't show it. And I have to know the difference, because what I don't want is for somebody to say, hey, all you're doing is creating magnetics under the ground, and that's what's lifting it. But in the end, it's going to be one or the other. Either it's going to lift because of the bubble, or it's going to lift because there's a whole bunch of magnetism under the ground. In the end, it's going to be what it is. But I'd like to know ahead of time so I could put it out there as the correct thing instead of the incorrect thing, because that just leads to more problems. So I don't need those problems. Rather just do it right and show it all at once. So that's where the gravity flyer is at. And yes, I do work on it a lot. And I am trying to smooth some things out in the whole thing. And strange things happen in my front yard when I start working on it. Let's just put it that way. And it all depends if it rains or not, if I can get more energy into it or not, based on that rain. That also changes it because it's easily connected to the water on the table when you get it down that far and you get your ground in there. And again, we're not using the ground from our electrical panel. So you got to drive a spike into the ground and get it that far down. And my front yard, just so we're all aware, there's sand about this height, which is about 3 inches. I have about 12 inches of solid rock that are in there just to filter it out. And the bottom generally stays wet when you hit the ground level because my front yard, the areas around it go down into it. So it has to have that in order for the water to come out like a French drain. So just so you understand what you're dealing with there. So the moisture is usually there. Sometimes it dries up. California gets 100-something degrees out here, and that'll dry up over time. But generally, it stays fairly wet during the season it's in right now, and I can get a lot more energy out of it. So that's kind of where I'm at. Excuse me. Kind of where I'm at with that. Yeah, Steinmetz is good stuff. Yeah, absolutely right. Oh, dielectric field is just a fancy, correct way to say static. Well, actually, two different fields, and I discovered that the hard way. The static field's really destructive, and it's using the energy, where the dielectric is not as destructive, and it's more of a potential between both. So I don't agree that static's the same thing. So, okay, let's take a look. But as Steinmetz pointed out, the dielectric is a better term because the static implies that it does not move. Yeah. So. Churning the ether can have many desirable outcomes. It can have some undesirable ones. I can tell you that right now. Man, you start messing with the earth, man, and start messing with your back. It does have some undesirable consequences. You got to remember it's building an energy field under there with the earth when you're pumping it. And thank God I don't have it down to the water table because then it would get a massive amount of power, way more than what I want. But yeah, it definitely changes some things. And the energy comes out as cold. It makes my gravity flyer colder. To be very honest with you, it takes down 15, 20 degrees on the center plate of my gravity flyer all the time. So, and could just be the temperature of the earth. I won't discount that, but it does drop it. So maybe the fan in the Tesla coil or the cooling of the center of the Tesla coil might do it. You might be onto something right there, because when connected to the ground, obviously the whole thing gets a bit cooler, but it makes the cold part even colder. So there's something to that. Don't actually know specifically how to state that yet, because I guess I'll just have to show the test of it at some point, and you'll be able to distinguish it on your own. Where's Bernie? I see stuff here. I don't know if he's out at the job site right now or not. It'll pop in once in a while. Agreed. Okay. A field is dielectric, B field is magnetic. Yep. So let me ask you, toy maker. We always call it a field. Do you see atoms in that field, or do you see atoms riding the field? For clarification, hysteresis is the dielectric field that does flux, and the magnetic changes for the dielectric and back. Hysteresis is the loss due to heat, from what I understand. So, by the way, in a perfect scenario, what actually happens on that wire, not in a motor, you're going to get heat and it's going to dissipate, and you're going to get losses, okay? But in the wire, if you look at a DC, and I said this before, You get your DC pulse, you read it. I'll just do it from this side, and it comes up like this, right? Does like this, and they're just square waves. I always see that wrong. Okay, I don't think it's right. And the reason is because DC, when you turn it on, here's your normal center point, and DC starts up here. So why in the world would it be here? Okay, DC is up here, and then it should go as a square wave like this because you're actually pinching the energy down. And when you do that, you're creating heat in the actual wire. So that heat isn't a loss, though, because the heat is transferring into the amps, and then the amps, once it's like goes back into voltage. So you're going to get more amps into your motor, and then boom, it'll let go, and then it'll go less, and then you get more, and then you get less, just like that. So I disagree with how that it is showing up on your oscilloscope, and it's just for that reason, because we're talking about, magnetic field, close to the inside. And then you're talking about your dielectric being out here, okay, which is more your volts is the way I see it. And then they clamp, okay, and you can see it by your frequency because as soon as that clamps, your frequency goes down. And when your frequency goes down, your amps go up. And that's a proven fact on my meters when I do this, okay? So there's fluctuation right there, and you have to be able to see it that way because that's what's going on. You could disagree with the wave being upside down or not, but when you start messing with this thing and you find out the higher the frequency is, the higher the amps, the lower the frequency, higher the frequency, the higher the voltage, the lower the frequency, the higher the amps, and when you get a higher amp level, you get more heat. It's as simple as that. When you get more volts, you get less heat. And that's why I see it that way, because it's pulling those fields back in and pinching and bringing them back out. Now, you're not gaining anything you're just transforming from one thing to the next. You still have the same amount of energy going through the wire. So in a perfect scenario, there's no loss. Hysteresis is the loss of the energy due to heat. That's the way I understood it. Let's see. Yeah, I know you say it's got a saucer on the bottom. I'll be honest with you, I'm getting good results with the way that he actually had it. I don't want to say this. The whole thing needs to be a saucer shape. Okay? Flat out. And the outside would have to rotate properly in order to make this the right way. But that's not what he was doing. I'll tell you right now what this thing is. This thing is a field generator, and that's really what it is. Now, will it get to the point where it'll probably fly one day? Yeah, it probably will. Is it going to do it where you want to make a craft out of it all day long like this? Absolutely not. Not at all. This is like a part of your craft that actually did something different and you showed it, but it is in no way going to be the anti-gravity craft that you want it to be. It just won't be. It's a field generator. It's what it does. It generates two fields and one that goes inside the other, and it creates a field bubble. That's what this craft is. So, I hate to break that to anybody, but it's not going to be a great anti-gravity craft for the future. That's not what this thing is. So, yeah. It said flat bottom still no good. Well, yeah, it might be, but I will say this, and I guess you have to look at it different. Are you working on a positive and negative scale when you say that? Do you keep the top all positive and the bottom all negative? Are you seeing yourself, instead of those two plates like I was telling you earlier, okay, now is it simply the charge? Because now I have the plates, but I also have the charge, but I also get the center to saturate. So you tell me. I mean, I know you're dead set on that, but I want to try to keep it as original as possible in order to do that. One thing I did have to change is I had to put a lip on the outside. So I was running it flat and I could not get the correct negative and the correct positive to stay where they're supposed to without it. And that was one of the differences in order to pick up a lot more energy. So, and get a lot more push is that little lip on the outside. It's about, I want to say it's 1/8 of an inch. Okay. Probably a 1/4 inch when you add the actual rounded part. So total it's a 1/4 inch, but it's got to put the jagged side down, not out. When it goes out, okay, that it's just in the wrong direction. It's wasting it. Got to go down. Okay, you got to have that ring on there. Alexi had it. We paid no attention to it, and that was an absolute failure on our part. So, let's see. Need a way to bleed it if necessary to drop off extra charge. Well, yeah, there's a way. And basically be ready to take your hot wire and have a switch to it to your cold in the center. That's how you kill it. As soon as you use that energy in the center, instead of it staying where it is, you kill the field. You absolutely kill it. And that's why I never hook directly from my Tesla coil on the number 2 coil to it. And I always put the wire down it. You'll absolutely kill what you're trying to do. And it'll use all the energy. It'll drop straight down. So, yeah, that thing is, no, that's how you kill it. Talking potential, yep, potential differentials. Yep, talking about those. Like I said, there's a way to do this and there's a way not to. And you really have to understand all of it, I guess. It took me a lot of time to kind of get in the middle of everything and figure it out for myself. It's a real disaster because you got to understand this. You're looking for everything you possibly can. See what just kind of falls out of it at first, what you can notice, and then what kind of theory you can put to it to explain what's going on. And honestly, in the end, there's like 30 different things that are going on here. Which ones are the ones that you really want? Which ones are the ones you don't? Does it all matter? Because as soon as you start amplifying one, you ruin the rest. I'll tell you that. Every time I brought up the voltage too high, I've ruined it. Every time that I go to change it and I thin it out more than it should be, nope, start changing it, okay? Sometimes you have combinations of things. So when you thin it out, it starts to interact better with your Tesla coil field, right? And you're going, great, okay, but then it's not coupling the bottom and top plate. That's a problem too. When you change and put the lip on there, coupling them changes a bit, okay? So because the field on the center plate changes because of the angle on the outside, it now changes just a little bit. You're now getting a pure negative field on the bottom and a pure positive field on the top, but then your piezo changes. So I want to say this, when you tap the outside, when it's flat on the outside, it'll actually change it. But now that you put a lip on it, it changes that. So you have to have your piezo do the work for you, and you do not want to hit it super hard. I've gotten to the piezo where the point where it goes on there and taps it, right? And you're getting this thing to change the octave on it to get it right. Now, we were talking a little while back with Victor, and Victor says, hey, what you're actually doing is the cones. You're changing it between fields. So what does that mean? So if I want the field to be like this, okay, and I'm starting out in this, then it'll start turning. Boom, 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 till it hits the right one, and then I get the angle that I want. So it could be doing that. I'm not going to say that it positively is because it's something you can't see, but you know it's 5 times and, there's 4 different cones. So it makes sense. Okay. And the 5th one is a lift. But I do know this, once it's in the right area, it's hard to get out of it. Unless you turn it off and reset it, it'll stay in that zone and it'll stay picking up energy. And that's a beautiful sight to see. There's Bernie right there. Oh, nature only knows pressure and light. Right hand rule. Interesting. Let's see. Either way it works. It's pretty cool. Perfectly explained. Sorry, I'm checking them a little late, so I don't know exactly where we're at with that, but thank you. Let's see. Yeah, I guess I should really get on the Gravity Flyer videos again. That's my fault, guys. I should really start doing that because there are some questions out there about it. And, you guys may have the answers better than I do all the time. It's not an easy thing to work on because it's so picky on what it does. Static isn't measured in the heat. You'll still get a charge. See, this is the thing, guys. You're just looking for the charge on this thing. And throw all that static out the window. You're looking at scalar or dielectric and you want to charge. You do not want stuff that's overused energy in this. It's a waste. Complete waste. We're not making an ion lifter here, not working on the same principle. We want energy field bubbles. Maximum amount of energy we can get into that bubble so that when we hit that piezo buzzer, we make it amplify. So, guys, what's going on is, say it's 25 megahertz, right? Well, it shows very clearly on your oscilloscope what it's doing, okay? It's amplifying it. So 25 megahertz will go up to 100 megahertz, 200 megahertz, depending on where you hit that thing. It's good where you put it on the ring. If you could put it as close to the end of the ring before it shoots out, man, that's the trick right there. You're going to get a massive energy. Everybody says, oh, well, you're going to need a massive amount of energy to lift something. Well, not necessarily. It really has to do with, do you have the right energy in it? Because energy, it's like a whole conversation on its own, okay? And I mean that in the way of energy. So DC volts act different than AC volts. And when you go and cross streams, you get a real nasty big voltage that comes out of the thing that was setting stuff on fire, okay? You get nasty stuff. And then when you take taser voltage and you put it in there and you put DC through the center of it, then you hit it, you're also getting a energy that does not work together. So you got to realize that when you're doing this stuff, and we're not in earth energy. And I think earth energy is more like a piezo energy than it is anything we make. And that's really important to this. It's everything is different. So if I were a craft coming into Earth's atmosphere, I'd have to know the kind of energy it produces. I also have to know the frequency of the Earth. Then I could probably more regulate it easily, and it'd be easier to lift this thing. And then it sees it as part of the Earth, so then it's not going to destruct it and force it down. That's one of the things people need to understand. You're in the wrong type of energy and you're trying to convert it. Now, the good thing is when you pump in that energy, it stays in there until you put heat in the system. Then you put heat in the system, it all falls down. It all loses it. Okay. It's just basically on the ground, sparking out and junk. Okay. And trust me, I've done it the hard way. You know what I mean? And it's always bad. Always bad. Never want to put heat in this system. That's why I took the neodymiums and just chucked them. Well, put them on my top side of my toolbox, I guess. But metaphorically, I guess, or however you want to say that, I just chucked them. But basically, I use earth magnets. If I could get some Alinco magnets for cheaper, I would. I'd put them on there because it's aluminum. Once you start resonating aluminum, then guess what? You're resonating those two and you're getting more energy out of them. That's pretty simple. It makes it fairly easy when everything's aluminum. Then you don't have to worry about a ton of different frequencies messing with you, do you? You just keep resonating the same frequency. So, yeah, one of the other things I get all the time, why don't you put a copper plate in the center? Well, because copper plates will pull it in and you get ions off of them. And that's not what I want. I want that energy to stay off those plates. I don't want it to accumulate on them or suck into them in any way. I want that energy free flowing on the outside. And the more energy I give it, the more that eddy current kicks in and the more it pushes it off as a field. That's what I want. So I'm pretty happy with the metals on it. So how can we get in contact? I will. I can leave my email for you if that's what you want to do. Absolutely. So I'll leave it in there now. It says I can't post my email. Okay. Let's make this simple. It's old, O-L-D, man, M-A-N, Nathan, N-A-T-H-A-N. Last name is Bunten, B-U-N-T-E-N. No capitals in it whatsoever, at gmail.com. There you go. That's my email address. Send me an email. For whatever reason, YouTube has decided, hey, we can't always post this stuff, and I'm getting tired of hearing it from it. I should just get a sign. So, no atoms. Well, interesting. Do you, toy maker, do you see atoms at all? Or, because I see fields everywhere. And that's what produces when I start messing with stuff is a bunch of fields. Of course, obviously, we don't see the atoms, but do you think that they're there at all? So, in any capacity, by the way. Fields are just different states of ether, like ice water stream. Yeah. Straight Dope or Joe says that atoms we picked up. I tend to believe that as well in the rotation of everything. You do lose energy through heat. Absolutely. It's a complete waste of time. So, by the way, when we start to get into this more and you start to look at Tesla Colorado stuff, he put the rod right in the ground, right center of his Tesla coil, because he was trying to affect the ether. And the only way to do that or to get energy to pass to the ground is to put it in the ground. So why not have your rod going right to the center of it and put the correct energy into the ground? That's genius right there. That's how you do it. Okay. And I only know that from the experiments that I've done, and they're showing it. So that's got to be the way to go. Okay. The spark cap creates more amps, and I would say it probably does. I won't disagree there. Do I want more amps and more heat? I don't know that I do. Okay, I'm not looking for sparks at the Tesla coil. If I do, I'll put it on like a quarter wave AC, which basically, to me, that basically means you cut the whole bottom off the AC wave. You're only getting the tops, and that sucker sparks like crazy. So the gold little Tesla coil I have, 12, 13-inch sparks, no problem. I got a new circuit for it. As soon as it's tuned in, I'm hoping to get 15 to 18-inch sparks out of it. So, yeah, that's kind of cool. I have Tesla coils to play with and have some fun with sparks, but I don't know that I want a ton of amps, and I definitely don't want them to build up. That's for sure. I need those things to cruise as fast as they possibly can. Let's see. Ideally, so, okay, 100% mechanical. Preaching words. Michael, not mechanical, sorry. This device is only good for the concept of E energy you're working with. Yes. So, by the way, determining gravity. Okay. Determining gravity, I don't think it's that hard. Getting the energy into gravity to lift something is. And I'll say it like this, okay? We have a field outside of our Earth, right? We know it's there, okay? We know there's different layers to that field. We know that it picks up radiation and traps it inside that field, okay? This is not something that's debated. We know it's there. We have to deal with it when we try to go to the moon. So, what we're not determining is we have a field around our Earth. There's no way that that's the first field. If the core of the Earth puts out a field, there is no way the outside of the Earth is the first field. It's not strong enough. Okay? When we start looking into, if you drill down in Russia and they found the hole from hell, and it starts putting out all kinds of different sounds and stuff like that, right? Well, it sounds like an energy field to me. Maybe, maybe not. I don't know. It wasn't there. Okay. We have stories about Indians that had a hole in the ground and they were able to, produce some kind of an energy out of it so that when they drop something down in it, pull it up, there was something else in the bucket. Is it true? Is it not true? I don't know. Mel's hole. You ever heard that story? Got basically a hole in his yard that goes to nowhere. Is there a field down there destroying everything? So here's the thing. When you get lightning, there's actually stuff that pulls from the ground that comes up to meet that lightning, right? So we put lightning rods on towers so that we can actually make the connection between the top and the bottom. That means that bottom may be equal distance to the top. So if it's 25 miles to the top, 25 miles down is where I expect to find this thing. And there's an energy on top and bottom. The one on the bottom is going to be stronger, closer to the core. That's fairly easy to understand, just like rotating a magnet. The field closest to it is the strongest, furthest away it's the weakest. So what does that make us sit right now? We are on a plate that's filled with charge. We are basically in between the two high voltage lines in the center, filled with saturation. That's where we're at. So if we're in the dielectric field at the point where we're at saturation, it explains why we're getting nothing off the ground. It explains what's going on. So now, if you know what's going on, which side's negative, which side's positive? Do they see it as negative, positive, or they just see it as weaker and stronger? Okay. It could just be that it's weaker and stronger. In that case, we always say the negative is the weaker one. So that would be up here. And then positive would be under our feet, not at our feet level, but under our feet. Then we're sitting on a saturated plate. So that saturated plate is constantly being pushed on. Okay. And as it's constantly being pushed on, we have gravity. That would be the simplest way to understand this. How do you break the gravity? You have to find the field it's actually in based on the energy of the Earth. Then all you have to do is reverse the flow to the direction you want to go. That's it. That's what I think gravity is. I don't know, man. But that's the way I see it is. Now, one thing that really bothers me about experiments and stuff like that when you get to physics is they take linear objects or cylinders and they apply that to gravity. But when you put it in a sphere shape, it changes the gravity itself when you're dealing with the testicle. Sean proved that. I mean, he mapped out where that Tesla coil is and how much energy. Ton of energy at the top, ton of energy at the bottom, almost a null zone right in the center. That's pretty strange. It completely changes how we look at a sphere object. And you go, well, a magnet's a sphere. We can rotate that. It's not the same. A magnet is basically pointing outward in every single direction that it goes. It's a different field altogether. That is not the field that we're getting from the Earth. So just understand that there's some differences there, and physics will catch up, and then they'll start to see it as they get into an experiment that can show that. And to be honest with you, I wish everybody built that Death Star Tesla coil that Sean has, because then you start to see that, and then you start to make your calculations based on that, and then it changes how you see things and where things are on the Earth and how the fields are working. So that would be really cool. And I'd love for people to start working on that kind of tech in order to understand this problem better. To be honest with you, with understanding gravity, you're going to have to throw everything at the fan until something sticks. And that's just the way it's going to work. You're not going to define it in physics, okay? Because they're stuck in 1930s, 1940s technology with Einstein, and they're not breaking from that. No matter how hard you want them to, they won't. So all their mathematics is based on that. And I watched a video today. It was an hour long, and I literally wanted to cry. I wanted to take a white flag and wave it in the air and say, no more. I cannot take this anymore. This is absolutely killing me to watch this, okay? It wasn't the guy's fault. He tried to make jokes, but it was like making physics jokes, okay? And not regular people jokes. It was hard to watch, okay? Because you knew as soon as they brought out a cylinder, you're just screaming, the world's not a cylinder. It's not. Stop it. So then they start talking about falling and stuff like that. And it's like these two things fall at the same rate. Some people said the atomic weight might change that. Okay. You say everything's based on magnetics. Well, what if it's not? What if you're not taking that ether into effect here? Then your whole equation is wrong. Your whole equation has to be modified for that. That's what I'm trying to say with the plate in the center. There's a whole nother thing that's going on here that we're not really getting to in science because they don't see it that way. They can't create that in the lab. Like I said, take Sean's Tesla coil and let's create it. He's got a north and south pole on this thing. And like I said, he's got real high amount of capacitance top and bottom and almost a null zone in the center. And it would make a great understanding to put another, just an empty shell around it and see what you get. Then it might compress it some more, depending on what material you have. Say you grew some homemade crystals in it and put it around it. What would happen? I don't know, but I'd love to. I mean, that's the kind of stuff, experiments you got to do. You got to take these things to the next level and start working with things that mimic what you're looking at, not what you assume them to be. I have a big problem with that. And that video, I gave the guy a thumbs up and watched it, and I was appreciative of it because it helped me with a lot of theories that I was looking into so that when I talk to Todd later, I have it. God, I wanted to cry. I was begging the guy to be done talking, and I didn't want to hear it anymore. It was just so bad. So let's see. My understanding that is if we can use a ground in the craft against the ether, the dielectric field, gravity should just ignore us. Well, that's kind of the point, isn't it? We should be able to float in the field. So a little bit of propulsion goes a long way when you are ignored by the gravity itself. That's kind of the point here, isn't it? And by the way, when you push energy in it from the piezo, just understand there's a little plate that it sits on too. So it sits on this little plate. You're pushing energy down. You take the top plate, if it's actually doing in the same direction, it'll push it down as well. The center plate, once you push it a little bit, you hit the other side of energy. It goes from a positive to a negative. You flipped it. As soon as you flipped it, it now has an attraction towards that small little disc on the top. Push it, and it bounces. Hit the diaphragm, and it jumps. Okay? Take the little, balloon, put your finger on it on the table, and let it jump. 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 That's what this gravity flyer doing. That's what it's set up to do. That's my understanding of what's actually going on here. So Richard says that he matched the gravity flyer and measured the stuff. If I showed you everything on it, then yeah, you'd be able to map it. Part of the problem is a lot of people try to do the equations based on the equations in physics, and it's not applying to that right now. It's not in that realm. The energy's different. So I keep trying to tell people, I try to nudge them in the right direction. I do the test. I know what's going on, but I can't change minds. I can only tell you what's going on. It's up to you to see, if it works in what you're doing or not. We're all here to learn. Yep. I'll be honest with you, man. I don't have to be right in any of it. I just don't. Because when the right answer comes, we're all going to have to change what we're doing anyway. That's a fact. You imagine if you got this thing to lift and you break gravity. Okay? What in the world's going to happen? How is every scientist in this world not going to want to knock on your door and say, how is it working? Why is it working that way? What equations can we do to show this working? Just imagine that. That's what we're up against here. It's not, mess around and do something and do the wrong thing here. You just can't. And showing a false positive would be the worst thing in the world. The worst thing in the world. Because then some people would always believe it, be a conspiracy theory around it. I don't want any part of that. You know what I mean? But in the end, you just have to be honest with what it is, though. I'm okay with that. But I want the answers to be able to be dictated based on what it's doing. Bring people in that can evaluate it correctly. Let them make their determination. And then go with the consensus. That's it. I don't have to be right. I don't even have to do anything. I just have to do my job. Be the mechanic on the situation. And that's it. That's all I want to do. Do not want any more. My name doesn't have to be on a paper. I don't really care. This is what I like to do, and I have fun doing it because I love experimenting. That's as far as I want to take it. Once it's up in the air, somebody else take it and have a good day with it. And you tell me what happened. Tesla coil should be the core of the machine. Yes. So, does it have to look like a Tesla coil, though? No, it does not. It has to function like a Tesla coil. Does not have to be a Tesla coil. Okay? Sounds confusing, right? And it goes to this. If I create a diameter this big, right? But I only made it this thick. But I still put a little wire around the bottom. Is it still a Tesla coil? Well, yeah, if it can oscillate and I can get one magnetic field into the neck, could be that thin. Still Tesla coil. What if I took geometry of a wire and I made the top set and the bottom set resonant to each other? Turn pulse this one then in turn pulses from it. Okay. As long as I set it up correctly, then I can still get the same thing as a Tesla coil. Because all we're looking to do is take it and make it an air core transformer. So that's really the effect that you need. Does it matter the geometry that you use? Well, Sean just told you no. He created a sphere, right? Oh, this is fear. Okay, we've all seen the video by now. And he's got this coil coming up like this, and he had to put it at 30 degrees. Couldn't keep it at 90. He had to put it at 30 because he was getting an interference pattern with it. So, and it also matters that he round it this way around on the way up, okay, and not this way. Makes a big difference on how you can put the secondary on because they have to be wound the same direction. So, with that being said, you don't necessarily need the traditional looking Tesla coil. You need the functionality of the Tesla coil. And that's the most important part. If you can get that, you're set. So also, it's easier to work inside of a cavity. So if you create the center as a Tesla coil, say it's this tall, right? Say the ship goes on the outside like this, and you have, top goes like this, and bottom comes in like this, and you have it out. Now, inside that is the cavity. Okay. We're not talking people yet. We're not at that stage. We're just talking, little small flyer. Okay. But you have that cavity. Now energy is pressurized in there and it'll continue to grow. As it continues to grow, okay, you're going to get more of the fields that you want. Now, there's ways to do things that you can make a battery on the outside. So you take the inner plate, you put a battery-like material on there, maybe several layers, put a top plate on it. Now it acts as the battery for the entire craft. And then what do? Spin that sucker, right? Tesla turbine. Get it to spin as fast as you possibly can. What are you going to do? You're going to pick up energy from the atmosphere easily. It's going to go into that Tesla coil, create cold energy going down. The higher you go, the more energy you get. The more it's put into the battery, the more it goes into the system, the faster you can make it go. It's an interesting concept, isn't it? It's kind of where we go next after we understand how this one gets in the air. But that'll be the project after this when somebody else is looking at how this would work. So hopefully that helped you out in that. And yes, the more that you can get the thing cold in the center, the better off you are. Okay. And never, and I mean never, try to take the primary circuit and loop it. Just don't do it. Take that out of your head now. Here's what you want. When you get a primary circuit, we'll just say it's a coil in the system to run the coil, right? Or the Tesla coil. We'll just say it's a Tesla coil. Okay, we get it to run it. I'm never taking that primary energy source and looping it from the primary. This system is done. Okay? Power source, system running, good to go. Never want to play with that. Now, where's your secondary system? When you put the wire in there, that's your secondary system. It now will always keep the energy full. Keep your cup full, okay? Full of energy right there. So no matter how many times you tap it from the energy when you put the wire in, that cup's always full. You get what I'm saying? That's why you never loop it. You never change the energy in it. You don't do anything with it. You simply run it. It runs on its own. Now, when you pull the energy out, what do you need? You need to be able to put that energy into something. Take a battery. Take a capacitor. Whatever you choose, okay, that's fine. Put that energy into there and store it. Once it's stored, take the stored energy that's in there. Now use that to drive the primary system. That way, energy's always in the center. Cup's always full. Got it? Energy pulled out is now it can be accumulated. Once it's accumulated, it's like putting a barrier right in between there. Hey, I am not taking energy from the primary system at all. It's going to continue to run. But now I can take the energy that I've accumulated and now use it however I want. Okay? And you can't tell me any different. It's mine and I'm going to use it. Okay? You'd be like a little kid, right? You're just going to run it over there and then turn it back to the primary system and use it for the primary. Just make a little switch. You're good to go. You have it. Okay? That's as simple as it gets. Where do people get screwed up on this? They try to take the primary system, put in and make it over unity, and then run it back on a loop on that primary system. Absolute failure all the time. As soon as you put a load on it, it fails. As soon as you try something else, it fails. Because that battery or the capacitor has to be your firewall. It has to be, hey, we're not breaking the primary system. We now have somewhere else to go with it. Okay. Doesn't mean that it's not over unity or anything. It simply means that you understood the system and you knew that you had to block out the stupid stuff, right? So don't get carried away on trying to, get it in that system. You're creating a primary system that's continuously creating voltage, continuously create something that you can pull energy out of. And I'm giving you the secret. Just put the wire in it and pull the energy. That's it. Put it right into your battery, okay? It's as simple as that. Get the energy to go in there. If you have a pulse frequency, which the Tesla coil is, it should pulse as well. Because again, cheap wire, it's going to pick up the pulse rate of the Tesla coil, and it's going to spike continuously. What is that going to do? Lead acid battery, it's going to knock off all that grunge and garbage that's on those, post-its in there, and then it should run. Are you running on a different energy at that point? Yeah. You're running on a potential energy at that point, and you can pull as much out of it as you want and convert it. Great thing about a battery is that it already converts it. When you put it in as potential, it converts it over to a DC voltage. Pretty easy, right? We can all understand that. That's a fairly simple chemical process that's working as our full bridge rectifier. I mean, Bedini showed you that. Put in the energy in there and then use it as DC. You say, well, that's dirty energy. Well, I'm sorry. Get your hands dirty then. You know what I mean? Get all the energy you can. Convert. Start working from there. Get the spikes in there. Get the energy in there high. You know what I mean? Create the battery. Or put the battery as your shit, man, and be able to get it from the actual outside of the air based on the pressure and everything else. Get this thing to work, man. Get it all to work for you. I mean, that's kind of the goal here, isn't it? I mean, I don't really care what you call it. You can call it free energy over unity. I could care less. It's like taking, what's that place? Anchor Watt. Take the layout of Anchor Watt. Put a Tesla coil right in the center. Your primary Tesla coil. Put on each one of the towers, put a pickup coil. The exact same winding as your secondary of the original Tesla coil. Now what do you get? You got energy going into those. Do you put a load on it? No. You take the channels of water in between it and you fill them up and you put salt in there and you create a saltwater battery. Now what do you have? Now I have my primary that always runs. I have 4 pickup coils that go into my battery. Now my battery can be used for whatever I want. Okay? Now I can pull as much as I want and I never stop the fountain from running. It continuously runs and runs and runs. Why? Because I never messed with the primary source. I allowed it to run. Secondary picked it up in resonance, went into my saltwater battery. What if I want to run my primary bigger? Well, then let's put 6 this way, 2 this way. So let's go up to 8. Okay, we went from 4, we doubled to 8. Now I got these 4 that's running, these 8 that's running, all based on my primary power source, all going into my saltwater batteries and in the actual water source. Captivate, create a moat, keep all that water in there. Now guess what? Now I have a whole system of water in there that I can produce energy. Will you have to put something in there, for the water itself, like a shell or something or acrylic? Sure, you might have to, but you still have energy and water. So depending on how you pull that energy, if you put the cold side of energy into the water, it's not going to hurt you. You put the hot side of an energy, it's going to kill you. So there's a difference in the 2 types of energies. Okay. One's good for the earth. One's bad for the earth. The hot side's bad. Cold side seems to like the earth. Okay. You want to see how Tesla got that energy to go through the ground? And by the way, he was not trying to get it to go through the air. Let's just get that clear. When he was in Colorado, he's pushing the energy through the ground. 4 miles down the road, he puts a light bulb in the ground that lights up. He didn't wave it in the air. He didn't get in an airplane and check it out. He put it right into the ground. What does that tell you? He's putting the actual energy into the ground to the center of the Tesla coil, pumping it into the ground so that 4 miles down the road, he put the light bulb in the ground. He's got energy. Cannot use hot energy to do that because it'll just be destructive and it will not carry the distance. Has to be the cold side of energy. That is the main difference here. They said that Tesla sat in France one time and connected his machines to himself. And they didn't say how he did it, but that he glowed purple. And I always thought it was an interesting story, and it came back to a test that was done. Can you create a Tesla coil and get a purple glow out of it? Well, the wire down the Tesla coil, turn off the lights with a heavy enough charge on it, it glows purple on a junky wire. Kind of tell you what Tesla was working with, and now you know that this is the energy he's working with. This is how he's doing it. This is how we're going to start to create energy the right way. Okay? That's the way I see it. That's the way the experiments are proving it out. And eventually somebody's going to write a book about it and add circuits to Tesla, which are probably stolen when he died, that he already knew this stuff and nobody wanted that out because it would really ruin a lot of things. But, you know, one guy at home isn't going to change that. You know what I mean? I'm not an energy company and I have no desire to be one, and I'm going to keep paying my energy bill every month and I don't really care. Okay? But I just want to do the tests and find out what happens. And I found out. So now you know. That's what's going on there. So a lot of cool things to it, guys. Some of the things, bismuth. Never work with business. Okay? Love to work with it. Never have. Some people say that they have and they had experiments, and I haven't seen a lot except for a neodymium magnet spinning in it. Would I love to put a bismuth plate in the center on any one of my extra gravity flyers? Yes. Just for the sheer thrill of it. Just to see what it does. I'd love to do it. Don't have it. I'd have to make it. And to be honest with you, I haven't found the time to be able to do it based on the experiments that I do and the live shows that I do. There's just no time. So, but yes, if somebody wanted to, connect with me and do that, I would absolutely do it. That is an amazing thing to work with. And I'm just thrilled at the fact that, it's got the magnetic property to it and everything else. Oh, let's see. Oh, there it is. They actually did show my email. So if you want to contact me on my email, go right ahead, guys. So they might have did that on Facebook or something because we do Facebook, and we also sorry. Yeah, we do Facebook and Rumble on here. So let's see. By the way, that Gerald's coil is like out of this world, dude. So some really cool stuff. Yeah, definitely, Joe. You guys always rub off on me. So always something different. Wires act like mirrors. So if the wire puts out a field and then another field like a mirror, I don't know, maybe. I'd rather think of it like if I shoved a rod down a hose and turned on the hose, and all I did was kink it every once in a while, it'd build up pressure, and as soon as I let it go, it would shoot out. I mean, I guess that's more of what I would think, but I guess mirrors work. I guess you'd have to see that. Kind of something. Maybe it works out perfect, and I just don't know because I haven't seen it yet. But it might. Oh, God, guys. Yeah. By the way, if you ever see the I always call it the wrong name. The Y files, because it's like what files. Absolutely love Mill's Hole. It was hilarious. So, and the fish, the fish is on another level, bro. That's just so awesome. I love that show. Mel's Hole. Oh, let's see. Ferrofluid. Yeah, I might try that here in the future. You know what would be a cool idea is if the center was some kind of a clear, like acrylic with a pocket in the center. Then we can stick ferrofluid in there, and then you'd be able to see exactly where your fields were and where they went and stuff like that, and where the impressions are on it, what would happen when you rotate disc. That would be a cool experiment in itself, okay, right there. Just to see where the ferrofluid would go, maybe even, put things around one just to test and see how the fields are working. That might be a really cool experiment. That might be something to really look at when you get it going. So I might look into that one. That so transparent PLA, make it, and then put the ferrofluid in there. As long as it seals enough, you know what I mean? That might be all right. We're not looking at weight and lifting it. We're just looking for where it goes. So, man, that sounds really cool, actually. Oh, let's see. Yeah, we got a lot of stuff coming up tomorrow. By the way, Joe with the peg cell should be on the program tomorrow, Monday. We're going to be talking peg cell. We're going to talk microwave experiments with Joel. Now, some people said it's legacy. Somebody says it's Legance. I'll have to ask him in person, but absolutely love to talk to him tomorrow with the peg cell and stuff like that. I think it'd be right off the chain, man. Totally cool. So looking forward to that. Just really, really looking forward to that. So I'm really happy that he said yes. So, man, that's going to be cool. Let's see. New Star Trek episode. So I think I offended somebody with my last one really bad. So I could do another one. I think I may put it on the I just made a Facebook page for the French think tank, and I might drop them there, and I'll drop a link for them for everybody. But yeah, I got to keep doing them, but I got to keep it to the crew members and not anybody else, because I think I offended somebody. And they didn't say anything, but I think some people who watch the show and they just want the science, they didn't really appreciate it. So, and then there's a part of the audience, man, that absolutely loves them, and they're hilarious. And I think they're the greatest thing ever. So I'll find a way to make a balance for that for everybody. And then we can all enjoy them. Like Ken says, 5-watt laser versus 5-watt lamp, both 5 watts, but only one of them will burn your eyes out. Well, yeah, that's true. I do actually like Ken Wheeler, by the way. Some of the stuff that he says, man, you kind of have to sit there a while and let it process in your brain. But yeah, I actually do enjoy his program for things, and then I turn it off when he gets into politics. I'm not really interested. So, let's see. So, gravity is the Earth pulling the ether with a velocity that holds up the surface. It pulls in the ether and then turns the lava and makes the Earth grow. I showed you in the Frisbee experiment. Well, let me just talk the Frisbee experiment. Let me clarify something. When you put the energy in and you have tinfoil on the top and tinfoil on the bottom, okay, whether you put it on the bottom of the rod or the top of the rod, if it's all connected, you're going to get energy that flows through it. Now, if you remove most of the amps, you'd see a directional shift on your scale. If you left the amps in there, you're going to see a minimal directional scale drop, and that's normal. Okay. So I saw the experiment. I wish you would have moved the two plates further apart, put the energy directly on them. You would have got a higher amount on that scale. I can take some of this stuff with paper in the center and push over a pound. So, I mean, a couple grams, that's cool. It's a start, but you're going to have to adjust and get those things further apart so that it wants to pull down to it. Make the make the smaller part on the top, so the smaller part always tries to get to the bigger part. You know what I mean? So it'll force that direction down. So, and by the way, it would take forever to take that plastic and charge it up enough. It's not mesh; it's solid plastic, so it takes a long time for that to convert in order to get that pressure. So, I do like the experiment, though. By the way, like I said, but a couple more things, you have that thing at a very high amount really quick. Okay. Oh, yeah. He's on a transport you ride safely. Good thing Mike was there to transport you. Oh, always have fun with that. Okay, where are we at? Had a craft fly right over my head, maybe 200 feet above. That would be an interesting story. I love stories like that. Man, no sound. Yeah, that's cool. Now, did your hair stand up? Was there, or was nothing? Probably just nothing. Probably just got like tingly in your gut of what's going on. In Alabama Hills, just outside Lone Pine. Does it say Alabama? Is that right? Alabama's nowhere near California. Oh, let's see. Maybe there's a little town up there I don't know about. Nathan, you ever get the feeling that you are repeating yourself a lot? Yes. And you know why? Because you're still not listening. That's exactly why. Everybody wants to tell me how it works, but I'm the one working it. I mean, has anybody understood that yet? Like, I should know if these things are working or not. And it should be self-explanatory when I start saying things and how they work. We should listen because that's what the experiments are showing. So, yeah, I do repeat myself a lot. What's up, Gerald? Yeah, he's correct. So apparently I said something right. David, I called mine a potential cube. I don't know what that is, but that sounds pretty cool. Oh, let's see. Oh, hey, everybody. Ether ping pong, yeah. Man, I must be really far behind in what's going on, man. So, I was correct on something up here. Let's see. Let's get down to where you guys are at in the chat. Wow, you guys really have a lot in the chat today. Ken said that a lot. Ken repeats himself a lot. I've noticed that when I watch him. Yes, he does. So, heard anything from Joel? Yeah, we were just talking about that. Joel will be on tomorrow, Monday. I confirmed it on email, and I'm looking forward to that. Joel's a cool dude and smart as well. I absolutely agree. Oh, did I finally get to the bottom of this? Okay. There we go. Power supply is named a potential Q. Nice. Just hanging around, huh? Let's see. For sure, pigtails are interesting. Yes, they are. So I actually like the idea of being able to create energy, you know what I mean, out of a solid state. That's just cool to me in any way to do it. And hopefully I'll learn a lot more. Okay. Let's see. Why do most people believe that gravity cannot be a repulsive force, or rather that it makes a gravity wave extra special? Well, I'll tell you why. I was watching it today, and they still think it's a magnetic force. And that's where they're at with it, because they think there's an iron core at the center of our Earth, which I'm not so sure that there is. I can believe there's magma there. Magma, running around the Earth would create a magnetic field. That I could see. But it's more likely that there's a resonance chamber somewhere in there, however you want to form it. And most likely a lot of crystal in there. And that's just the way that the world's been built. And I would imagine that it goes through some kind of a gold layer. And that gold, man, that's a whole different animal right there when you start using it. We don't do a lot of experiments because we can't afford it. You know what I mean? Gerald had some really interesting results when he used gold. So, and silver. And Sean's coming out with a Tesla coil with silver. So that's really cool. So we'll get some understanding of what these things are doing. I think that's really awesome. But you know what I want to see? He creates fractal patterns when he has that sphere Tesla coil. He's creating fractal patterns in the thing below. So I told him, hey, why don't you take some clear PLA and just build another bowl, not a bowl, like another sphere on the outside, leave some room in there, and see if you get fractals on it from the energy. And if you do, then hopefully that energy will push out and create some light in there and get those fractals, or maybe just take it off and put it on a light bulb later and see what the fractal patterns are that appear on your walls from that. That would be completely awesome. I mean, who wouldn't want to tune in to see that? I mean, you got me there right there. As soon as I see the fractals on the wall, man, it'd be really cool. And do I have any information on the Cora Castle? Pulse DC. That's what he was using. He had batteries from cars hooked up in connection. Were they in series or not? I don't know. I do know that he actually had his motor when it runs, because of the way it has the top piece that looks like a four-leaf clover. It was actually creating pulses out of it. So Pulse DC is what he was using. Now, how he actually used it and connected it to coral, I don't know. But I would imagine he had a sound component. He had energy that went in there. So, a little bit of energy, a little bit of frequency. I bet you that thing moved real slow. So he's going to get a low hertz. And that's all it might take. Okay. He may have known something that we didn't, that he was able to figure out by looking at all the stuff. By the way, when they show the two tuning forks on that statue, and they show the wire in between them, right underneath there's a four-leaf clover. Okay? Maybe that's what he understood about it. He sees the Baghdad battery right there in a lot of their artwork. So he thinks DC. He sees the four-leaf clover, so he thinks the pulse on that DC. He sees the tuning fork, so he knows he has to have a frequency. Generally, tuning forks are in 400 to 500, hertz, not kilohertz, hertz. So it might have been the answer right there. He might have put the pieces together and said, hey, I got something here, because everything that he shows that. So, and it also shows it on the walls of Egypt when they start talking about the resonance. Okay. It's a pretty interesting concept. What's this? I've been wondering about a coated aluminum core wires a long time. Well, yeah. I got some aluminum outside to see if we can't get some aluminum oxide in the weather. Well, when it actually gets to raining out in California. So, silver is the best electrical conductor. Is it better than gold? So, I'd be interested to know that. I heard he used solenoids. Contactors. Tap, 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 tap on the energy in order to create the pulse wave. That'd probably be right. I saw that in a video. So I don't know if it was that or he actually got the thing and it went, at a slow pace and then boom, real quick. Slow and then real quick. I don't know. Contactors would probably be the fastest way to make a pulse DC. I can tell you that. Land of Chem. No, I do not. Let's see. Not much. Excuse me. Not by much, but yes, and it resonates better. Well, hello. Let's talk Egypt again. Resonance. If you're gonna know Egypt, you better know resonance. That right there, man, game changer there. Totally different than what you might think. So, yeah. I always say this: the Egyptian cross is a symbol for resonance, and you could tell based on where they put it in their hieroglyphs. And I wish more people would see that. It would make a lot more sense when you get to the next part of when we start talking about the coils and where they're going. It's going to make a heck of a lot more sense if you really understand it that way. Let's see. Silver is better, but gold has less reactive, does not oxidize. I don't know what that is. Terphenol D? I don't know what it is. Let's see. From what I've read, conductance is silver, copper, gold. Yeah, copper's next. We should all make rodent coils from silver wire. Yeah. You got a bunch of money over there, David, that we don't know about? Because, what was it? 5 or 10 pounds of that thing? What, $2,700, $3,000? I can't afford that. Sorry. I'm not rich, man. I'm retired. I'm old. You know what I mean? I got to worry about putting gas in my truck. So gold is not the best system if you run it really hot. Yeah, I can see that. But how do I want to say this? I probably can't say that, so I won't say it. All right. Sorry, I had to go through the train of thought. Bifilar coils made of silver can do more amazing things. Yeah, there's a whole side of this, guys, I can't talk about, and I would absolutely love to. But yeah, matter of fact, there's two sides of it I'd love to talk about that YouTube just won't allow us to talk to you about. Electromagnets lifted stones, really, and then they release them, and the power is disconnected. So that would be interesting to see, because I don't know that electromagnets would truly do that. They don't build up enough charge on the surface. And I honestly think it's a charge on the surface that changes the direction of something. So I would love to see the coil do that. And I would be a believer for life if somebody showed that to me right in front of my face. But I'll have to wait till that day. You know what I'm going to say? Yeah. Well, you start messing with those materials, man, you're going to get into a different direction, aren't you? Yeah. So let's see. Yeah, the theory on iron oxide is used to transfer electrical current from lightning bolts to when it hit the pyramid. Yeah, Discord, same thing, man. They'll throw you off for it. They don't allow people to have the freedom to talk about this kind of stuff anymore. Some kind of effect right there. Rochelle salts, yeah. Piezo. Man. You know, it's a video I wanted to show you guys, but I don't know. I'm going to check right now. YouTube says it's okay, but I think I'm just going to leave the link to it. And I'll pull that for you. There's a couple of them. And this one's really interesting right here. This is about coil and numbers. Okay. And I could probably play this one, but I'm going to leave the link to it, and then I'll play this one. Okay. And there's another one. So let me pull the other one real quick. And it has to do with sonic geometry. Yeah, you're kind of missing it, Gerald. So I left the other one in there, but I just thought this was interesting, and I believe if I saw the frequency of it, it was 427. No, 432. It's all about the number 432 hertz, and it goes on and tells you examples of where it's used, what it's dividable by, how you actually get down the line with it, with the resonance. And those are both awesome videos, by the way. And then the one, and I don't know how much of it I want to show, but it was talking about how he took rodent coil numbers and he transferred them in with getting rid of the zero, and then how that worked out for him and some of the stuff he did there. So let's see. Let me... All right, I'm going to pull that one for you guys right now and share it. Oh, which one do I want? This one?
Chaos is the absence of matter, basically. So where is the absence of matter? I don't know if a lot of people knows about it, but actually the absence of matter, so the vacuum, is actually the distance between every component of reality, which is actually between the planets. Of course, you have some void between the planets, but you have also void in between the matter itself. Into a molecule, for example, a molecule is composed of different atoms, and between each atoms you have actually more space that we actually think it is. When you come inside those atoms have space also, and inside of these atoms you have some quark, and the quark have also some space. So actually space, vacuum, void is actually everywhere in reality. So
it's a constant.
It's a constant, exactly. So if it's everywhere in reality, it's a constant, and we all know mathematically that when you have a constant, these constants normally disappear, because if you want to quantify something, you have to quantify something out of what is everywhere. So if the space is everywhere, what's the point to keep it in our mathematical system? Especially when you understand that this vacuum, this void, is actually determined by the absence of matter. And this is where it starts to be a bit tricky. Like, why do we keep something which is actually everywhere, especially when its own definition is based on non-matter? So this is basically when I start to think about it and start to see actually what's going on when you remove the zero from the decimal system, and see if there was another way to actually quantify the reality without using the zero.
Yeah. So if we're quantifying matter, then we need to eliminate the constants, which is no matter.
Yes, correct.
So in a practical application, you would say 1 times 0 does not equal 0. It's a 1. There's a 1 in there in the equation. You've got matter multiplied by vacuum, 0, absence of matter. So you still have matter. So 1 times 0 would equal 1.
Yeah, so logically.
What's up, Joe?
Hey, it's Sunday. What are you doing?
Same thing as always, man. Getting online, talking to people.
Yeah. I was in the chat. I was trying to hang out a little bit.
Right on. So you hear all what's going on, man? We're just talking. Like, you tell me I keep repeating myself.
Well, I mean, you do, but it's for purpose of the fact that the same exact questions and conflicts come up over and over again. And it's like, trying to reword the same stuff to get people to grasp it. What are you gonna do? And look, I mean, people have to remember too, there's more than one way to go about these things, but the road all leads to the same outcome. So you got to balance it out too. Not everybody's project's necessarily going to look exactly the same, but as far as what this group is doing, it's following the principles that you preach all the time. And I mean, from everything I've seen, it's all on the right path.
Yeah, we definitely got to go in the right way. I could tell you that. Yeah, some of the discoveries, man, when you start to overlap these things and see where they're going, it's just. And I wish I could say the other side, because it'd make so much more sense to people. They'd finally get why I'm so excited. You know what I mean? And I can only tell you about the Russell scale and then transmutation, and not say the other stuff. And it's like, you know what I mean? It's right there, just right there. And man, yeah. But some of that stuff with the gravity flyer, man, I have to tell people, because they're still not. I write it down. I tell them. And then the next day I get, well, why is the center plate copper? It's like,
yeah, I know. Well, if for what it's worth, and not playing devil's advocate with you all too much, but
go ahead.
The material that's out there on this is so much content that to expect any person that's loosely following and just checking in to see what's what, it would be hard just to get a quick update and not hear the same thing or whatever. Like, that's just what it boils down to. Like, there's 10 hours of content minimum that comes out a week from this group, so if you're 3 weeks behind, you're going to spend an entire, the 2 or 3 days of waking hours listening to it in the background, just to extrapolate out a couple weeks worth of progress on a few years worth of journey. So it's tough for the person that's not super dedicated, I can imagine, but
yeah, I can see that.
The progress is there, the stuff is there, and hopefully the people in the community are using the information that is out there and known and that is repeated all the time, using that to actually get their systems a little closer to working as well, because frankly, and it's not an insult to anybody, lots of opinions, but nobody's is flying.
Yeah.
So, for what it's worth, right? So everybody's in it for the same reason, and just got to bear that in mind.
Yeah, I'll be honest with you. I wish there were more projects like mine out there. That way, you know what I mean? You could conversate about them. There's not a whole lot out there.
Yeah. Only recently I started looking at, what other people even did or where they started, or even, I guess, like where you were tied up into those, earlier stages and stuff, when I guess it was more based on Alexi's work, and trying to just replicate what Alexi was doing and everything. And I only very recently even went down that rabbit hole, and what I've come to learn from us talking and just being part of the community and everything, even just on the theoretics level of things, this is so much more advanced than it was 1 year ago.
No, it is.
This is a whole entire different conversation. It's a whole entire different system. It's a whole entire new machine. It's showing all the right signs, not only to function, but to function at a level that was never even discussed, thought about, or part of the equation of Alexi's original design.
Yeah,
so
that's for sure. Well, a lot of it is you kind of go down rabbit holes with this stuff too. Like once you get into that Tesla coil and you start messing with it and you have to read up on Tesla and how it works and why it's doing and what it's doing, it's like a whole rabbit hole in itself, man.
I mean, here, let me grab something real quick. I'll be right back.
Okay. Nice. Only care about experience. Right on. Let's see.
Like we were showing some books yesterday when we were on and whatnot.
Oh, yeah.
Right. Like here's one book, and this is a good resource on Tesla's work. Okay. And this is only what they're writing about. This isn't any of his suitcase stuff and all that good stuff. Look how thick this book is.
Yeah.
And this is on 100-year-old Tesla work, and it's 500 pages. And then you have a whole entire library worth of 500-page books that you read and you sort, and you have to figure out how it's relevant to what you're trying to do and this, that, the other thing. It's super easy just to have a general idea of how the things ought to work ideally, but in practice, it doesn't always pan that way, Yeah. And it's just so much knowledge to have in order to even be a proactive part of the discussion, frankly. And people have like little good ideas, and those are the things in the community that you have to grab onto and be like, that's an interesting tidbit. I'm going to put that to the side to see where that fits in,
Mm-hmm.
And that's what this is all about.
Yeah. So, I'm sorry, I was reading a comment over there. So, well, you know what? I hope he has fun over there watching the crop circles. Not really worried about it. You know what I mean? So, whatever. No, but I think we're gonna have to probably get some more experiments in here when we do this stuff so people kind of see a little bit more so that they stay in touch with it. You know what I mean? As well as the talking. It's kind of hard when you're doing the show because doing experiments on air sucks. I'm going to tell you that right now. It really does. And something always goes wrong. And then everybody's chatting about something else while you're frustrated trying to do something. Oh, God, is it a nightmare?
Yeah. No, I understand. And I can imagine that that's easy to become like a little disenchanted with the whole thing. But, people also have to remember with these casts, especially, this is to keep the community engaged and have that open chat and forum. And, like, for what it's worth, any of these like types of casts and whatnot between the people that are, you know, just trying to like that are regularly on here and whatnot, it could easily just be done like, you know, in the back room, not available to anybody to see, but who does that benefit? You know, this is the unadulterated, you know, think tank of, you know, some nonsense, some banter, and a decent amount of information if you're following the conversation and the topics, you know. That's it. Just people have to appreciate it for what it is, man.
Yeah, well, we'll get on with it, man.
Yeah.
I'm over talking. You know, so yeah, we're turning a new page here probably in the next week or so. Joel's coming on tomorrow, and that's gonna be exciting, man.
That is really exciting, you know, because I've heard good things. I'm not super familiar with his work, but I've also literally went to go look it up and see what I could find, and then I was like, you know what? I think I'd rather go into that just right at face value, you know, and meet it right where it's at. So, yeah, I'm super excited because I've only heard good things.
Yeah, because you got that peg cell, and I don't know if you heard anything about it or know anything about it, but he basically, I think it's Pepto-Bismol or something crazy, or I don't know, some kind of active ingredient, puts it in there, and then it hardens, and he's able to get energy out of it. Okay,
Out of bismuth.
I made it not that. I'm sure somebody in the chat knows exactly what kind of stuff it was, but Magna something. It's not magnetite. Anyway, it's just a over-the-counter product you could buy.
Oh, okay. I got you.
And he put the not copper, but cell things in there. So he built a crystal cell that John did, and then he created his peg cell. And I don't know.
I wonder if it's magnesia. Yeah, meth, exactly.
There you go.
Get your chemistry on. Oh,
Gerald
polyethylene glycol. Oh, okay. PG. That's all that is.
Yeah. Sorry.
Nice.
I should have known that, but that's what he puts in there. And then he hardens it. And sometimes he'll put I think he put copper in it last time. And he's got a couple of them, and they've been around for like a year, and they still produce the same amount of energy. So I thought that was so cool.
Yeah, PG is really, really neutral, viscous stuff, you know, like that's crazy. I can't wait to hear how that works, because like I didn't even know that it really had a use other than you know, kind of being a carrier of something. Like usually, you know, they use it as a suspension, you know, as a base for a suspension.
Yeah.
I think they also use it in antifreeze. Yep. There it is.
There it is right there. You caught it. Yeah.
And my vape juice that I'm always sitting here like.
Yeah, it's a catalyst to a carrier. That's what Gerald says.
Yep.
So yeah, it's going to be really cool, man, because I just want to see how it's done. You know what I mean? So I can do it. And
awesome.
Talking to the man himself is exactly where I want to be.
Yeah, no, I'm definitely looking forward to that, and you know how that plays right back into the same hand of cards that you're playing over there, because you're going to need two good, reliable cells to be able to break the locality on the system. That's really what, you know.
Yeah, well, he said he was able to put it in an ice cube tray and get 12 volts by putting multiple ones together. That's what was really cool. Fascinating. That's all you need.
Yeah, so think about how big that is. That's awesome.
Yeah, that got me excited. I was wondering if they were like just regular ice cube trays or popsicle ones, or you know what I mean, like that tall. Because then you can really, if you can get it to amplify and multiply like that, why not? You know what I mean? So
yeah, the craziest stuff can be batteries. You know, like you know, it's really true. I mean. I don't want to like, you know, talk about someone else's work because like it's their thing and they haven't discussed it. But look, two common household items, you know, like one rubbed against the other. That's it.
Yeah.
And then you sit there and you all of a sudden you touch it and you're like, oh, look at that charge.
Yeah.
You know, and that's it. It's like, oh,
Well, we were
that's
doing
something.
something for my son's science experiment once, and it was like a potato. You know what I mean? And you put it in there, and then you do a lemon, and you think the lemon has more acid, and then you go, okay, let's put it in a tomato, right? And the tomato was better than the lemon and the potato, so even better than both of them put together. It was so interesting to see which ones had the stuff, the chemicals in it to get you your battery.
Yeah, man. It's funny now that I'm thinking about it. You just jarred my memory because I think the first exposure to anything like what we're talking about was my dad just making me a science project for no reason. He was always good like that, you know. But
Nice.
he took 3 2-penny nails, you know, just filed the tips of them flat, wrapped some copper wire and electrical tape around it, and you know, put a 9-volt battery port to it, and he's like, hey, look, you just unplug and replug one of these terminals and then look what it does. That puppy used to get hot.
Huh. Nice.
Yeah, but it was strong, I'll tell you, man. It was right off the bat.
Well, I
School
did.
got into trouble.
So for a junior high science project, man, I blew up hot dogs in the microwave, and then so funny. And then I blew up beans, and then I think I tried to blow up my cornflakes one day, and you know, I mean, just the stupidest things in the world that you could think of. And it wasn't just cracking the hot dog, man. I wanted this thing to just splatter. So I kept leaving it in there for longer and longer, and it shriveled and shriveled and shriveled to this little tiny thing. But then the best part was I had to get in front of the class and describe what I was doing, okay? And all you had is this long-haired kid sitting in there telling him about how he's blowing up hot dogs and microwaves and how excited he was about it, right? The teacher took one look at me and think, this guy's full of it. You know what I mean? You're not getting a B or an A. You're getting a C, buddy. We know that you did that last night. You know what I mean? Well, yeah, I needed something. I at least got the little board and drew pictures of the hot dog. So
Yeah. It's funny how those things go, man. Those are the days, though. This is where it all starts out. So any of the people in the audience, you know, you have kids, when they bring home those projects, you know, you might feel like sighing, you might feel like, you know, putting your foot down and going, well, you got to do it or whatever. Get involved, teach it, you know, teach them the best way to do it and why, because it right, you're telling the story right now, and you know, I remember that from 30 years ago.
yeah.
You know, I'll tell you another one real quick is, see, my parents were divorced when I was growing up, you know, and my mom sent me to my dad's one day, and all she said was, he has some kind of science thing due on Monday. That was it. She didn't send me with any of my paperwork, nothing. You know, it was just me and that. So my dad goes, oh, well, what's the science project? I was like, oh, I don't know, something to do with like, we have to build like a boat. It has to float. Okay, because we were doing like buoyancy in school.
Okay.
So he's like, oh, okay, cool. So he goes and he brings me outside, and we go out to it was a sarsaparilla tree because it smelled like root beer. I remember, you know, we cut like, you know, some branches off of the sarsaparilla tree, and we made like this raft, and you know, it was like really crafty and looked really good and had a mast on it and like Lego men on it and stuff. Like it was cool, and it floated. You know, it was like, all right, mission accomplished. There you go. So I'm all proud coming into school with like my little raft and whatnot with my Lego man, and like I'm sitting there smelling it like it smells like root beer. I'm like,
Nice.
and then I get into class, and because I didn't have the paper, the the assignment was to build something that floats with the goal of it being able to hold the most amount of weight while maintaining its buoyancy. This
Oh,
raft was not up to that task.
nice.
The first weight that went over it flipped over and dumped the weight. The second weight that went on sank it to the bottom. It was like, well, it's done.
Oh, that's so cool.
Yeah, but you know, my dad didn't know. What are you gonna do? He tried his best.
Yeah, we used to have the gutters where we put the little popsicle sticks and let them go down and see who got there faster.
Yeah.
We had the side hack. You ever have one of those?
No.
You had
What's
your
the side hack?
bicycle, and then you had the metal part that came over with another wheel, and you get to stand on it like a chariot. Okay, so dude, we used to like pull the thing to the side so that you were tripping like this. You know what I mean? And the person's holding on like this, like it's a Roman chariot. You know what I mean? It was just the coolest thing in the world, man. You'd go over jumps, crash. I think we all got skinned up with that thing, man. It was like dangerous, but it was the funnest thing in the world.
Yeah. Yeah, man. I did Boy Scouts with my boys for a long time, and the first year I did the Pinewood Derby with them.
Yeah.
And I let him do a lot of it. But he was only 7 years old. So how much is he really going to do at the time? Because he was like a Cub Scout. So he did bunch of it, but I helped him out. But the car did good. So the second year, he looked at me. He goes, "I want to win." And I was like, "All right, take a seat."
Yeah.
He worked on that car nil. He picked the colors and the design.
Yeah.
And helped me do that aspect of it. But that car was so fast. We made it to nationals in Times Square.
Really?
On that
That's
car.
cool.
Yeah, it's cool, but I built the thing, and I even felt guilty about it.
Yeah.
But then again, I was like, all right, most of the cars that made it to this national level, the dads probably built the damn cars anyway. So,
Yeah, that's for sure.
yep.
Huh. Right on, man. Yeah, I talked to Todd later today, man. Got the interview on his paper, man. I'm kind of excited about it.
Very cool.
I've been up for the last 4 days studying on this thing because a lot of terminology. There's a lot of things to look up, a lot of theory, ton of math. Okay. And then just the basic experiment and what he's doing.
Is that going to be live?
Yeah.
On your channel or?
Yeah, on this channel. So that's going to be 2:00, if I'm not mistaken. Yeah, because it's 5 his time. He's on the East Coast.
Yeah, so 5 my time. Okay.
Yeah. So a couple hours. So probably do this another 20 minutes and then
yeah, man. No, that's cool.
So anyway, I'm excited, man. And first time I get to talk to Todd live, and he's always on my Gravity Flyer chat and always telling me to correct my language and stuff like that. Because it's not physics language, so I'm sure he's just gonna hammer me for it. So we'll see.
Yeah, but go in there expecting it, and to make sure you have a paper and pen with you. So
I do.
And just jot it down as you go, and that's that. And
like I said, I was watching a guy today about what physicists think about gravity, right? Joe, let me tell you, if I had any hair right here, it would be gone. And it was just frustrating. You know what I mean?
Mm-hmm. Oh, I do.
And it's now I understand why they say what they did. We don't erase theories. We just build upon them. We just add and add and add and add. And I'm thinking, well, maybe you should really throw some out. You know what I mean?
Yeah, right. The cart gets a little heavy after a while. You might want to.
Because the basis was, it was what, 1940s with Einstein, maybe 1950s, somewhere in there. And I'm thinking, didn't we have a better base than that? I mean, that can't be the gold standard still. And it wasn't much different than the apple fell on your head. Let me tell you that. It was a lot of linear thought.
Like all of those theories are, it's not that they don't hold weight in this. It's that, like anything in life, there should never be a hard set rule for something. It should always be a point of guidance, because the dynamic of anything, whether it's scientific or not scientific or anything, it's all based on circumstantial, environmental and circumstantial influence. So
the story was much better than the actual math.
That way. Good. It's a great
Well, they-
guidance is where I'm going with it. Like, I mean,
Yeah.
stuff checks out, but it checks out until it sort of doesn't. And when it doesn't, you don't say, well, if it doesn't, then it can't because it's not described. When it doesn't, you have to sit there and look to fill in that gap. And sometimes the gaps don't need to be filled in. That's another thing too. Just because something's missing doesn't mean that filling in the gap is the right thing, because sometimes something missing is something in itself. I find that the where science goes wrong a lot of the times is they get caught up with a question
Yeah.
based on an assumption, a question based on an assumption, but the question's wrong. They're not asking the right question. The answer is there to be had. It's just not where they're looking because they're not looking for the right thing.
Yeah, it was just kind of frustrating, man, because I'm thinking they had to do better by now, and I didn't see it, and the guy didn't call me a schmuck, okay, but he said that whoever doesn't look at it this way is like deranged or a Looney Tune, or it was something derogatory, okay.
Yeah,
And I'm thinking, well, that's not good to say. You know what I mean? You could just said, hey, you may have a differing opinion that doesn't follow with the mainstream. That would have been something cool to say. You know what I mean? But now I understand why they are the way they are, because I didn't get it. Like, why aren't you listening to new ideas? Well, because we're set in our ways. You know what I mean?
well, because it's an attack on their profession. Like I'm an insurance adjuster. There's certain things that I know to be inherently and unequivocally true. Now, me personally, because I'm an open-minded person, who likes to consider all these different dynamics and things, maybe I don't fall so hard into this, but there's several things that, like, if you bring up to me in point of conversation, as especially from a layperson, like, and I hear it all the time from people not in my business, where they say things that professionally I know, I'm like, that's literally not the way it works.
Yeah.
Like, what you're saying is that's bad information, and it's literally not the way it works. Me being me, I won't shut them down. I'll still hear them out. But once they get the point out, and I could say, well, here's sort of more how it is, and probably not for that reason, then if they still don't agree with me, then there's no helping them. Like, what do you want from me at that point? But like, you can't be indefinitely right about everything either. So if you're going to be butthurt just because you're a professional, which shuts you out to every other piece of information, well, who are you doing dirty then? Yourself. That's my opinion.
I had,
but their perspective is that this is an attack on what they fundamentally know to be correct, that they base their entire career off of.
yeah.
So,
I can see that. I had a guy kind of like that. What are we going to do? The boss isn't here. We can't make a decision. And we're trying to fit this corner cabinet in. There's bricks there, right? It's about 1 foot long and, maybe like 4 inches deep, right? And you got a lazy Susan going in the corner. Well, I don't need to call the boss. I don't need to go take the whole thing apart. Give me my saw and get out of my way. You know what I mean? So all I did, cut the corner, turned it, flipped it, so now it goes like this. Boom, put it back in all together, slid it right into place, and was done. You know what I mean? Simple as it can be. You know what I mean? Hey, I don't have time to deal with all this other extra garbage and drama. Let's just get it done. And
yeah.
You know what I mean? It's about being open-minded and stuff about it too. And the guy just goes, well, I'll just listen to you now. So then we started doing the job sites a lot faster. It was like, okay, we're going to go hang a thing of cabinets in one day. And I'm not sitting there for 5 days. So that was cool. So I love that when people do that. And they've been in this thing a lot longer than I have. So
yeah, like the whole, whether it's like you're talking about like building materials or structural materials or human beings and dynamics and all these things, the number one thing that ought to be important to people is resilience. There's nothing better than a high level of resilience, because you can make something stronger than steel, let's say, and it'll be stronger than steel until it catastrophically fails under its own rigidity, and then is not worth, what it's holding up at that point, right?
Yeah.
Whereas steel, it'll bend, it'll flex, and and then after, if you get it before it reaches complete failure, you could bang it right back into shape.
Yeah.
That's resiliency, and if you think about that in the human psychology aspect of things, people that really don't bend all too much in the wind, and if they get hit, they could take the hit, and maybe they'd be banged up, but get banged right back into shape. Those are the people that remain standing. When you're too rigid, you're only as strong as until you break. And that's where all this is right now, so just know to roll with the waves a little bit, and be the steel, not tool steel either, because that shit like to snap.
Yes. Yes, it does. I've seen that. Just tears in half. You ever seen it just tear in half? Oh man. That's
High carbon
stuff.
steel is like a favorite thing of mine. Like in fact, I wanted to do like a part of an episode on Faraday steel. That when Faraday back in the day did all of his different steel experiments, he did all sorts of different alloys and stuff, including precious metals and all sorts of stuff.
And what did he do with them?
He was just trying to improve the quality of steel. By making different alloys. They didn't have all the alloys figured out at that time, in the 1820s and whatnot.
Gotcha.
So he came up with a whole bunch of different stuff. I don't have like a list in front of me. This is off the top of my head. One thing that comes to mind though is he actually did silver steel, and they actually found an improvement in the ability for those steels to hold an edge and be more resilient and less prone to oxidation, like rust oxidation. But the only thing is that there was no real cost benefit there. There was other ways around. So it was just a trial and error process that he went through. It's little known because it was a trial and error process. There were probably more failures, or things that just lacked practicality, even if they were successful. That was found during those experiments, then there was successes. It's still worth knowing though.
Yeah, I'd love to take some aluminum wire, you know what I mean, and do some experiments with it. I don't know of anybody out here where I'm at that has it, so as soon as I do, I'm gonna have some fun, man.
Yeah,
because there's got to be some cool stuff to do with that. Just because the eddy currents on it alone, when you start putting DC into it, it'd be totally different feel, different coil, different everything. I even thought, hey, let me take my coax cable and I'll just wrap it on one of these rodent coils, right? Just to see what it does. So
no harm, no foul there. If you have the frame, you're couple wraps away from knowing the answer, aren't you?
Yeah. Oh man, I wrapped a printer today to send to Canada. The shipping on that?
Well, I'm sure the duties is probably going to be just as much as the shipping, Gerald. Sorry.
Oh my Jesus.
For a printer, I don't know, like $100, $90.
Oh, it was more than that.
No.
It's 50 pounds because of the box and the stuff that I put in it, right?
Okay.
So in the States, it's anywhere from $50 to $130. Let's go to Ben. Okay. And so Michigan, California, and Michigan. Okay. So then to Gerald, and I don't know if they take them out and inspect everything or what they do when they get there or how that whole thing works going to a different country. But yeah, it might be close to $200. But then I go, okay, let me check the price of those things in Canada, right? Well, they're $400 and something.
Yeah. Okay.
And I'm going, okay, well, it's still a deal. You know what I mean?
Yeah.
So Man, it just sucks though. I was hoping it's like, $50 and send these things out. You know what I mean?
Yeah, yeah, no, that's tough.
So
Did you
I
break
gotta
them down or you just packed them up?
I broke them down, packed them up. I wanted to keep them as big a pieces as I could, just so it's easy to put back together. But it might just be because it was going such a further distance, right? So adding a little more cardboard in there in some places, they may have brought up the weight. But then again, it's going to be slammed around until it gets to Canada. So I
Yeah.
don't know.
Have you tried any different filaments and stuff like that? Like, do you have stainless steel nozzles and so you could print some more abrasive
So
filaments? Or
yes, I did, and I sold the printer, but I was able to print with like metal shavings of iron. So I had iron filings in it, be able to print that, TPU and some other stuff.
yeah, TPU's cranky stuff, man.
Yeah.
Yeah, it's cranky stuff. I feel
So
like resin's so much like it. Like it's at the point now where you know
yeah,
resin might be the way, to be real.
but all the chemicals, man, I didn't want to have them in my house.
I don't blame you there. Yeah, a lot. Well, some of the systems now they have closed ventilation built right in,
Really?
which is nice. And you're still going to have alcohol and stuff. That. But at the end of the day, I mean, how are you more worried about alcohol or super saturating your entire garage with the static charge? You know what I mean? That literally makes your
Well,
laptop bug out.
it may have
You know,
different consequences for some of that stuff, huh?
right? Which is worse? Not really sure.
Yeah, I don't know. I just kind of stick with the ones I got. You know what I mean?
Yeah, for sure.
I already bought them, already use them, like them. They form stuff fast. You know what I mean?
Oh
If I
yeah,
have,
for what you're doing, I mean, it would be a waste of resin, and it's just for the simplicity of being able to add stuff into the resin
yeah,
to then have it print. So like you don't have to depend on some formula somebody else already came up with for filament, because I would imagine that making your own filament is probably just like that's like a lost cause. Like why at that point,
I
So
don't know. I seen people take 2-liter bottles and then
yeah,
they put them in that machine and makes them, and they add a little bit of plastic to it.
yeah, I've seen that too. I don't know, man. People just have like more patience or attention span than I do. I don't know. Good
Yes,
for them.
me as well. So I just get it done, get it formed, because I'm going to put high voltage to it and I'm going to tear half of it apart. So it may only last me a day. You know what I mean?
Yeah.
It's like, okay. Sometimes it lasts longer than that. And then I'll go there and go, okay, well, let me just print a real nice one, right? Then the real nice one doesn't last a day. And it always backfires on me. So I find the
Yeah, it's tough.
fastest program possible and push them. And then that's it. So,
Nice.
yeah. I like the 3D printers, though. They really make a big difference, man. I was excited to get my first one a couple of years ago. And then it became a hobby to get as many as I could. And then, eventually you get done with that hobby and you go, well, now it's time to get rid of as many as I can. You know what I mean?
Yeah.
So,
Yeah, I know. Trust me, accumulating things is fun, but at the end of the day, what good is it to have all those printers? It's unless if you're making a whole bunch of stuff, like at the same exact time, all the time.
yeah.
Now, a lot of people do like figurines and stuff like that. They find their piece and zen in that. They do miniatures and whatnot. So I'll tell you what, man, some people are really, really good at it.
Yeah, I've seen that.
Really, really good at it.
Well, like, if I need something really nice, man, I'll just pay somebody to do it. Like a helmet, I don't have patience for that. I really don't. I would love to have a bunch of them, and I have no patience. So, and then getting everything so finely tuned and things like that, no.
Yeah, I mean, everything's got its pluses and minuses. I mean, whether you're doing filament or you're doing resin and whatnot, but I feel like the tolerances and stuff of resin is just way better. And even though it could screw up, like it's not gonna, most of the time it won't screw up as bad as like, I mean, I've had some filament disasters where it's, I walk away for like a few hours and I come back and I'm like, but you were fine when I left.
Yeah.
Like, you have
Oh,
a bird's nest and
there's
20
like a
bucks worth of
big
filament
ball that
wasted.
connected to the end of your hot end.
Yeah, a nest like this big and shit flying all over the place and the thing's still printing and it's like, what?
Or
Yeah.
the printer head just hovering over the top like it's doing something. Yeah,
It got possessed, right?
I had those a couple times, man.
I'm telling you. Yeah, no, that's crazy stuff.
Oh, all right, Joe. I think I'm done for right now, man. Because
Yeah, man.
I got this in a little bit. I appreciate you coming on, though.
Yeah, of course. No, thank you for having me as always. And if nothing else, for the chat. So
Yeah, right on,
all right. Well, I'll see you in the chat in a couple hours then.
right on.
Get
Guys,
some rest,
thank you in
brother.
the chat for everything. I really do appreciate it. And then we'll be back with Todd here at 2:00. So,
Catch you later.